Hi everyone, this is the class for Karnataka State Open University first year BSc CBCS scheme second semesters subject chemistry, code is DSC 1 point. In this module, we learn the concept of vapor pressure, the definitions of this vapor pressure, compositions, diagrams, boiling point, classifications into the types of ideal and non-ideal solutions, Raoult's law, deviation from Raoult's law means the positive deviation and negative deviation, and fractional distillations, Azeotropic mixtures, binary mixtures of completely miscible liquids, finally applications and numericals of this topic. We know that binary solutions, binary means two components mix with each other. It gives a binary solution. In that two component, what is the small amount or small portions of the solution, that is called what? Solute. In a solution, the large composition or large proportions, that is called what? Solvent. Binary means it is a homogeneous mixtures. When two components mix with each other, it gives a homogeneous solutions. In that homogeneous solutions, the small portions of the solution, that is called solute. In large portions of the solute, that is called solvent. Consider here 100 ml of water taken in a beaker. 100 ml of water taken in a beaker. Add 2 gram of sugar into that water. To formation of a homogeneous solution, that is called what? Binary solution. Here 2 gram means that is small amount, hence that is called what? Solute. Here 100 ml means that is a large amount, that is called what? Solvent. In this, consider some other examples of this. Consider air is a homogeneous natural gas, sea water, gasoline, body fluids. These are all what here? The substances are found in the nature or the mixtures of pure chemical, pure elements or compounds. We consider this reason for widespread occurrence of mixtures is that there is a natural tendency for entropy to increasing in mixing. The well-known example here in that atmospheric air which contains a mixture of nitrogen and oxygen. Consider here fully ionized plasma can be taken as a mixture of ions and electrons. The thermodynamic properties of a mixture depends on what? Temperature, pressure and compositions. The binary solutions or binary mixtures Generally, we have to discuss that vapor pressure of a liquid-liquid solution, vapor pressure of gas-liquid solution. When a solute is added to solvent in order to prepare the homogeneous solution, the vapor pressure of the solution is increases or decreases compared to the vapor pressure of the pure solvent. Consider a water. Water is having some specific vapor pressure value is there. Once we are going to add in a non-electrolyte solution, the vapor pressure is changes. If a non-volatile solid or liquid, the vapor pressure of the solution is equal to the partial pressure of solvent in solution. In the solution, if the solute is volatile or solid or liquid, then vapor pressure of the solution will be equal to the sum of the partial pressure of the solute and the solvent. Mathematically, that is written as here P1 is equal to P1 naught into X1. Actually, this is explained by the law like that, Raoult's law. What is the statement of this Raoult's law? It states that for the solutions of two volatile liquids, the partial vapor pressure of each of liquid in solution is equal to the respective vapor pressure of the liquids, and the equilibrium partial vapor pressure of the liquid is directly proportional to its mole fraction. That is the statement of this Raoult's law. Here, consider a two components are there, component 1 and component 2. The mole fractions of component is generally represented by number of moles of that component by total number of moles present in the solution. Total number of moles present in the solutions means here M by M plus N. Similarly, we consider mole fractions of component 2. Symbolically, that is represented by X2. Here N by M plus N. According to this Raoult's law, we says that here vapor pressure is directly proportional to that mole fraction X1. Here P1 is equal to P1 naught into X1. P1 means vapor pressure of component 1 in solution. P1 naught means vapor pressure of pure liquid component 1 at the same temperature. X1 means mole fractions of component 1 in solution. Similarly, component 2, here P2 is directly proportional to that P2 naught into X2. According to that Dalton's law of partial pressure, the total pressure of the solution phase will be the sum of partial pressure of the components in solution. That is, P total is equal to P1 plus P2. Generally, the Raoult's law says that here the partial pressure of different components is equal to the total pressure of the solution, where P total means that is total pressure of the solution, P1 means total pressure of the component 1 in solution, P2 means vapor pressure of the component 2 in solution. Here, substituting these values, what we are getting here, P total is equal to the what here, P1 plus P2. What is that? P1 naught into X1 plus P2 naught into X2. This is that Dalton's law of partial pressure. Here finally, what we are getting here, we know that mole fractions is equal to what? X1 plus X2 is equal to 1. What is X1? 1 minus X2. Just we have to substitute here. P1 naught into 1, P1 naught minus P1 naught into X2. Here P2 naught into X2. We have to take a common factor here X2. X2 common factor, what is that? P total is equal to P1 naught plus P2 naught minus P1 naught into X2. Okay, this is what mathematical expressions for Raoult's law for the solutions made up of two volatile liquids. We can conclude that here P total can be related to mole fractions of any one of the components. It varies linearly with X2, increases or decreases with of X1. This can be represented on graph as shown in the figure here. Okay, just we consider this is obeys that Raoult's law. Here x-axis is representations of these mole fractions of the components. Here this is y-axis is in that vapor pressure. Here it is a what? Straight lines, curves it is getting. From the above graph it can be concluded that the plot of P1 naught versus X1 is linear, P2 naught versus X2 is linear. Maximum value of P total is equal to P naught. The minimum value of P total is equal to P1. Next we are going to discuss with what are the types of liquid-liquid solution. That type of liquid-liquid solutions here, the solution we are getting two types of solutions here. The solution which obeys the Raoult's law, they are called what? Ideal solution. The solution which does not obey the Raoult's law, that is called what? Non-ideal solution. A solution which obeys Raoult's law are called ideal solution. This liquid obeys the Raoult's law over the entire range of concentration. Here, two liquids A and B on mixing form an ideal solution. The molecules of A and B have similar structures and polarity. The intermolecular attractions between AA, BB and AB are like molecules. Okay. The ideal solutions are the following characteristics molecule. It's obey the Raoult's law. That's why here PA is equal to XA, PB is equal to XB. When these two components mix with each other, it is what? That enthalpy is zero. No heat is liberated or absorbed. Next we consider here delta V mixing is equal to 0. No expansions or contractions on mixing. This is what? Ideal solution. Next we discuss with Raoult's law curves for ideal solution. What is that ideal solutions? According to that Raoult's law, the partial vapor pressure of components A and B on ideal solutions are given in equation 1 and 2 respectively. Just we see here. Here the total vapor pressure of the solution. Curve 2 means that is vapor pressure, partial vapor pressure of the solution. Curve 3 means partial vapor pressure of the solution. We consider example of this, what? Ideal and non-ideal solutions. Before that, here ideal solutions can be obtained by mixing of two components with identical molecular size, structure. They should have almost same intermolecular attraction. We consider the intermolecular force of attraction between that AA and BB are same. Compare with that mixing UD polymer. What are the example of this ideal solution? Here ethyl chloride and ethyl bromide, N-hexane and N-heptane, carbon tetrachloride and silicon tetrachloride. These are all what example of this ideal solution. Next we discuss with non-ideal solution, that is called what? Real solution. The solution which do not obey the Raoult's law are called what? Non-ideal solution. the solution does not obey the Raoult's law. Means it does not obey the Raoult's law means when we are going to mix with two components A and B, it will changes. Non-ideal solution, enthalpy value changes and delta V value is also changes. How it is says that if a solution formed by mixing of two components A and B in which intermolecular force of attraction between AB are not equal to the intermolecular force of attraction between AA and BB. These new interactions AB is either it is less than or more than from the Raoult's law. We consider, suppose if it shows two types, one is that positive deviation from Raoult's law and another one negative deviation from Raoult's law. Suppose now we are going to discuss with here positive deviation from Raoult's law. Suppose for two liquid mixtures, vapor pressure of component A is greater than XA and XA naught, and vapor pressure of component B is greater than XB into PB naught. Then the enthalpy value is greater, increases, and change in volume is also increases. We consider example of this positive deviation from Raoult's law. Here solutions of water and acetone, chloroform and acetone. From this here, why this positive deviation appear? The two component is there A and B. When two components mix with each other, the vapor pressure is increases. Means the less interactions between component A and B. That's why. Here, this is because intermolecular interactions between A and B are weaker than intermolecular interactions between pure component AA and BB. This type of deviation is usually obtained by mixing polar liquids with non-polar ones. Next we consider this is the graph for that. This is ideal behavior. These curves is generally indicates that these curves are generally indicates that positive deviation from Raoult's law. Next, negative deviation from Raoult's law. Suppose for two liquid mixtures, PA less than XA into PA naught, PB less than XB into PB naught, they do not obey the Raoult's law. That's why here delta H mixing is less than 0, delta V mixing is less than 0. For example, here chloroform and acetone. Let's form an example. Here this is what? Ideal solution. These curves are representations of this what? Non-ideal solution. That's why it is decreases. What are the conditions forming non-ideal solution showing positive deviation? Two liquids A and B on mixing form this type of solutions when AB attractive force should be weaker than AA and BB attractive forces. A and B have different shape, size and character. A and B escape easily showing higher vapor pressure than the expected value. Next, what are the conditions for forming non-ideal solution showing a negative deviation? Two liquids A and B on mixing form this type of solutions when AB attractive force should be greater than AA and BB attractive force A and B have definite shape, size and character. Escaping tendency of both A and B is lower, showing lower vapor pressure than expected ideally. What are the differences for that ideal solutions and non-ideal solution? Ideal solution which obeys Raoult's law at every range of concentration, The positive deviation means it do not obey Raoult's law. The negative deviation is also it do not obey the Raoult's law. Here negative deviation. Next we consider here delta H mixing is equal to 0. Neither is evolved nor absorbed during the dissolution. Here delta H mix greater than 0, it is an endothermic process, it is a dissolution, it is absorbed. Here delta H mix less than 0, it is an exothermic dissolution, it is evolved. In that ideal solution, delta V means change in volume is equal to 0. Total volume of the solution is equal to sum of volume of the component. Delta V mix greater than 0. Here volume is increased after dissolution. Here volume is decreases after dissolution. Here it obeys the Raoult's law. That's why here total vapor pressure is equal to sum of the partial pressure of PA plus PP. Here there is no obeys the, does not obeys the Raoult's law. PA is greater than PA naught into XC. PP is greater than PP naught into XC. That is reverse of that what here non-ideal solutions with negative deviation. That ideal solutions, the interactions between component AA, BB and AB are same, but here the attractive force should be weaker than AA and BB. Attractive force A and B have different shape, size and character. Here AB attractive force should be greater than AA and AB attractive forces A and B have different shape, size and character. Next we consider here AB attractive force should be greater than AA and BB attractive forces. A and B have different shape, size and character. AB escape easily showing higher vapor pressure than expected value, but in negative deviation escaping tendency of both components A and B is lower, showing lower vapor pressure than expected ID. Next we have to discuss some diagrams of this vapor pressure. Here in that vapor pressure we consider two components, ideal solutions containing the volatile liquids A and B. The partial vapor pressure are given by Raoult's law. Here PA is equal to XA into PA naught and PB is equal to XB into PP naught. Consider the total vapor pressure P of the mixtures. P is equal to PA plus PP. Just we have to substitute to finally we derive this one here. P is equal to PA plus P star A plus P star B into X. Just we draw the diagram of this. Here more fractions, here vapor pressure. This is what vapor pressure. Total vapor pressure P can be related to the component composition of the vapor pressure. You have to write that. This is because A is more volatile compound. Volatile at all the composition. The reverse graphs is obtained if we plot the mole fractions A in the vapor pressure of binary solutions. This is the graphs for that vapor pressure. Next we have to discuss about that distillation. What is that distillation? Distillation is a method of separations of two individual components from a liquid mixtures, which depends on the differences in boiling points of the individual components and the distributions of components between a liquid or vapor pressure in the same. We consider the phase diagram. For the phase diagram, here binary mixtures, phase diagram, only two component mixtures, A and B are considered. There are two types of phase diagram are as follows. One is constant pressure phase diagram and constant temperature phase diagram. Constant pressure phase diagram. Constant pressure depending on the relative concentrations of each component in the liquid. Many boiling point temperatures are possible for mixtures of liquids as shown in the phase diagram below. For a mixture, the temperature is called bubble point temperature. When the liquid start to boil and a few drops when the vapor starts to condense. Boiling point of liquid mixtures takes place over the range of boiling points. Likewise, condensation of vapor pressure takes place over a range of condensation points. Next, constant temperature means a process which can take place at constant temperature. That process is called what? Isothermal. That is a phase diagram for that isothermal. Constant phase diagram of two binary liquid mixtures is shown in the below. The constant temperature phase diagram is useful in the analysis of solutions behavior. The more volatile liquid will have a higher vapor pressure. Next, relative volatility. It is measure the differences in volatility between two components. Is termed as relative volatility. This indicates how easy or difficult a particular separations will be formed a binary mixtures. Relative volatile components A with respect to components B of the mixtures is defined as like that here. Ya means that is mole fractions of component A in the vapor. Xa means mole fractions of component A in the liquid. Similarly, we have to replace what? With the help of this mole fractions. What for a binary mixtures? Xb is equal to 1 minus Xa. That is substitute in that equation 1. What we are getting equation. The above equation 2 non-linear relationship between X and Y. These equations can be used to determine the equilibrium relations provided with average relative volatility. Here, alpha average is shown. It is known that if the system obeys Raoult's law, what happened here? PA is equal to P into XA, PB is equal to P into YB. The relative volatility can be expressed as like that. Okay, where PA is partial pressure of the component A, PB is partial pressure of component B, T is the total pressure of the system. Next, vapor pressure completely miscible liquid-liquid mixtures. Here, when two liquids A and B are mixed, generally we have to following the possibilities. Liquid A is completely miscible with liquid B in all proportions. Liquid A and B are only partial miscible in each other. Liquid A and B are completely miscible with each other. These are all what? Here some following possible examples regarding to that. Here vapor pressure completely miscible liquid-liquid mixtures. Now first type of mixtures of miscible liquids. For this type of solutions, the vapor pressure curve exhibit a minimum. If we take a mixture which has an excess of X, we are somewhere at C on the curve. When this is distilled, the vapor will contain excess of X and thus the remaining mixtures will get richer in Y. Okay. In that, the second type of mixtures of miscible liquid. Here, the vapor pressure curve records a maximum at F. Just to comparison with this diagram also. Then you have to find out. The boiling point diagrams, it depends on the temperature composition curves. The liquid is started boiling when the vapor pressure of the liquid is equal to atmospheric pressure. Suppose we mix two liquids, let's say A and B, with a definite composition. They form ideal solution if the molecules of A and molecules of liquid B are not interested with each other. How to distillations of an ideal solution? Let us consider the binary mixtures of two liquids A and B obey Raoult's law. Vapor pressure of pure A will be higher than that of pure. Consequently, at constant temperature, the boiling point will be lower than of B. The relative composition of the vapor phase over a solution can be known by Van-Wall-Ox. What is the statement of this? In this, distillation of a binary liquid mixture has compared to the liquid phase, the vapor phase is richer in the more volatile components. Next, distillation solution exhibiting positive and negative deviation. This is what distillations of a solutions exhibiting positive deviation. Consider the distillations of a mixtures of component A. Then the first fractions obtained will have a composition shown by A. The mixture is richer in the constant boiling mixture. The composition of the residual liquid therefore will shift towards A as the distillation proceeds. The composition of the distillate changes towards C and that of the residual solutions towards A. This distillations of a solution showing negative deviation is the reverse of that positive deviations. In that, azeotropes. Azeotropes means mixtures of two liquids which boils at constant temperature like air, pure liquid, such that distillate has the same composition as the liquid mixtures are called constant boiling mixtures or azeotropic mixtures. There are two types of azeotropic mixtures are there, minimum boiling point azeotropes and maximum boiling azeotropes. In that minimum boiling azeotropes, the azeotropes are formed by liquid phase which show positive deviation from ideal behavior. Such an azeotrope corresponds to an intermediate composition with total pressure is the highest and hence boiling point is the lowest. Such azeotropes have boiling points lower than that of the pure components. Consider example of these azeotropes, minimum boiling azeotropes, ethyl alcohol and water molecules combine in a composition 95% and 5% respectively to form an azeotropic mixtures with constant boiling point. The maximum boiling azeotropes, these azeotropes are found by liquid phase which show negative deviation from ideal behavior. Such an azeotrope corresponds to an intermediate composition for which the total vapor pressure is the minimum and hence the boiling point is the maximum. Example, hydrochloric acid and water molecule combine in a composition 20% and 80% respectively to form an azeotrope mixtures with constant boiling point. How to summarize this? A solution means it is a homogeneous mixture of two or more substance. Solutions can be formed in all three types, solids, liquid and gases. Solutions can be divided into 9 types depending upon the physical states of the solute and solvent. A solution which cannot dissolve more amount of a solute at a particular temperature is called a saturated solution. Pressure has only a small effect on the solubility of solids in liquid. Completely miscible liquid phase may form ideal or non-ideal solution. Ideal solutions obey Raoult's law, called ideal solution. The solution which does not obey Raoult's law, that is called what? Non-ideal solutions. Okay. Ideal solutions can be separated into pure components by fractional distillations. Non-ideal solutions can be separated into 2 fractions by fractional distillations, 1 and pure component. And another constant boiling azeotropic. From this topic, generally we have to discuss that concept of here what is the relation between ideal and non-ideal solution, what are the differences between positive deviation and negative deviation states, Raoult's law, and discuss the phase diagram for that ideal solutions and non-ideal solution. Okay, these are all very important concepts regarding to that what theory of dilute solutions under that binary solutions. Thank you.